So now we're back with our second example. This example is going to be a production example. It's a little more complex than the first sales example, but still it shows how you can use this production to improve, this potential to improve performance, both for looking at saving costs as well as increasing revenue. So in this case, we've got a company, then it's a production company. We say that they've got sales in this particular case, this product, of 125 million. Okay, 125 million for this product. The cost of the materials, because we'll be looking at waste or scrap for this case, the cost of materials then for these products then are about 50 million. 50 million cost of materials, in this case for units being produced, 100,000 units, which makes that a cost of 500 each in terms of materials for these units. So 125 million in revenues, 50 million cost of materials, which means there are other costs plus profit tied under these sales, 100,000 units produced. Okay, we'll take a second and look at these numbers. Okay, now coming back, let's look at then how many operators do we have. In this case, operators, we say we have, once again to keep it simple for calculations, 50 operators. Now you can take a look and say, well, 50 operators, 100,000 units, each operator is doing 2,000 units, right? Exactly right, because in fact we've got a production line. Each operator has a similar set of machinery to produce these goods. So the real difference then in these operators becomes the quality control. Assuming that all other parts of the production line are the same, then it's maybe something that's going on that these operators are doing that can control waste. So we look at this, then once again we take a look at our top 10% of our performers, our operator performers. In this case 10% is 5 people. And we find, looking at the statistics that are available, that they are basically having scrap of about 5,000, or in this case what, 10 units are somehow wasted, scrapped, of each 2,000 they produce. And this 10 times the cost of 500 becomes a waste of 5,000. When we look at our other operators, our other 45 operators, the remaining 90%, we find that generally they are having about a 25% waste in this case, which is a 12,500 cost of scrap out of these materials that are being built. So in fact, they've got a higher average waste. Now when we do the calculation of the 45 people and the 5 and calculate this, we find that the total scrap is about 587,500 for the entire team of 50 operators. Now this seems rather high, a high cost, but at the same time we realize this is being applied to our overall cost of materials of 50 million. So this is still just around a 1% scrap cost. So not too high, but still it would be nice to get it better. So let's take a look at these figures then for a second. Now, coming back, let's figure out our basic PIP. Once again, a simple calculation. We take a look at our top performers, in this case a 5, versus the average 90%, which is a 12.5. Make a ratio out of it, and what do we have? We have a potential for improvement of 2.5 times, assuming we could move those 90% of people up to the same level that the other top performers are. So again, we stop for a second and look at those figures. Okay, so we're back now. Now let's take a look at calculating this scenario of the production scenario here on the waste. All right? So similar to the sales example, what we want to do is say although we would like to improve everyone to 100% to the top performers, we are realizing we'll be conservative, and first we'll just say, let's try to just improve 50% of these other operators, the average operators. There's 45 of them, so in this case we'll just keep it to around 22 operators we're thinking that can improve. At the same point then, even though we had a PIP of 2.5, we'll see if we can only improve to 50% of that PIP. So in this case, that's a what? A 1.25 change. Very conservative here. Now, in this case, if we're looking at individual improvements, then at a 1.25, they had a scrap of 12,500. In fact, what this turns out to be is the scrap then drops to about 10,000 per person. And that means an individual change from minus 12,500 to minus 10, you gain a 2,500 increase for each of these people. And of course, what we want to do, as always, we calculate our net gain, 22 people times 2,500. That comes out to a gain of 55,000 savings on each of these, which against our total of 587,000, this is a gain of what? Just shy of 10%. In fact, it's 9.3%. Okay, so now you've had a chance to review these figures. So really, what does this tell us? I mean, we have a chance of almost a 10% gain, but how do we get that? Doing this kind of a calculation, PIP, is meant to be a very simple front-end type of analysis you can do before you decide even to move into trying to solve some kind of a productivity problem, a performance problem. It gives you a chance to say, well, based on what we're trying to do, there is a chance to save money or make money by doing this. The next step, of course, and the key step is, what are you going to do to try to solve this problem? Many managers say, well, let's do some training with these people. But training is not always the solution, and in fact, usually it's one part of a multifaceted solution, because, in fact, these operators, in the case of this, may not need training. It may be something else that's going on in the whole process of what's going on in the factory. It could very well be some skill things. It might be some tricks that your top performers have learned to do that were never passed on. It may be more around motivation. For some reason, a few of your operators have a more of a motivation to begin doing these sorts of things. There are many possibilities. So the key before you take action then, once you realize that there are savings to be made if you decide to move, is to do a good analysis of what's the gap, what's the difference between the top performers and these lower performers. And once you know what this gap is, you can begin to determine, are these behavioral things? Are these psychological things? Are these differences in tools or lighting or who knows what? How often the boss comes by? We don't know what these things are. But once we can determine what those are, then we can begin to make changes to improve our results. And typically with most of these kinds of issues, it's not just a single solution. It's a combination and integrated set of several things going on that are pushed forward by the managers and supervisors and kept on, and that people are rewarded for the change. So I hope this about 20 minutes today was valuable for you in terms of finding out how, in fact, you can calculate these PIPs, and that as you begin to consider your future projects, you will do these calculations to give you a sense of what might happen. Of course, if you have any questions about this, I'm always available. Stephen Kelly at KNO in Bratislava. My contact information will be on the following slides. And I always would be glad to hear from you if you drop me an email or give me a call. So thank you very much for your time, and have a good day. Goodbye.